The third and final form of a line that will be important to our studies is called general form. The general form for the equation of a line is given by ax plus by equals c, where a, b, and c are real numbers, and of course, x and y there are the variables. One method for graphing a line in general form is to locate the x and y intercepts. As we learned in the previous video, the x-intercept is where the line crosses the x-axis, and the y-intercept is where the line crosses the y-axis. Now let's take a look at the x-intercept. Notice anywhere you're located on the x-axis, the elevation of that point is always the same. That is y equals 0. So to find the x-intercept, we're going to set y equal to 0. So the form of this x-intercept would be some constant and 0. On the other hand, if we look at the y-intercept, now no matter where that y-intercept is located on the y-axis, the x value is always the same. That is, to find the y-intercept, we're going to set x equal to 0. So the form for this y-intercept will be 0 and then some number, we'll just call it d. So let's apply this on example 7. Graph the line 2x plus 3y equals 6 by plotting the x and y intercepts. Solve for y to find the slope-intercept form of the line, and then we'll identify the slope. So let's begin by finding the x-intercept of this line. Remember, the procedure for finding the x-intercept is to set y equal to 0. So I'm going to go to my original equation, and I'm going to replace the y with 0. When we plug 0 in for y, this term is basically annihilated, and we end up with the one variable linear equation 2x equals 6. We can solve that by dividing both sides by 2, and we get x equals 3. So officially, as an ordered pair, we have x equals 3 and y equals 0. So our x-intercept is ordered pair 3, 0. We can go ahead and locate this on our graph. So the x-intercept for our line is ordered pair 3, 0. Now let's find the y-intercept. Remember, to find the y-intercept, we set x to 0. So you always set the opposite variable equal to 0. Now I'm going all the way back to the original equation, not to the work that I've done previously, but all the way back to the beginning. And this time we're going to replace x with 0 and keep everything else the same. When we plug 0 in for one of the variables, we lose one of our variable terms and we end up with a one variable linear equation. We can solve this for y by dividing both sides by 3, and we come up with y equals 2. So if we put this information together, we can generate the ordered pair for our y-intercept. Now remember, ordered pairs are always in order. In particular, that means alphabetical order. So x is first and y is second. So our y-intercept here is ordered pair 0, 2. We can update our graph over here with the y-intercept at 0, 2, and now we have enough information to graph the line. So let's connect these dots with a straight line, remembering to keep arrows on the end, and we have a complete graph. I'll go ahead and label this with its general form, 2x plus 3y equals 6. Now we have a little bit more to talk about here. Remember, the problem asked us to solve for y to find the slope-intercept form. So we had general form. General form was 2x plus 3y equals 6, and we want to rewrite it in slope-intercept form. Anytime you want slope-intercept form, the procedure is simply to solve for y. So I'm going to subtract 2x from both sides. This gives us 3y equals 6 minus 2x. Now, we know that our goal is to put this in slope-intercept form. Slope-intercept form is mx plus b. That is, the x term precedes the constant term. So I'm going to go ahead and reverse the order of these two terms just to start matching that slope-intercept form, being careful to keep the signs right. So I'm going to have negative 2x here and plus 6 here. Now, to isolate y, we need to go divide all of our terms by 3. And we end up with y equals negative 2x over 3 could also be written negative 2/3 x, and then 6 divided by 3 is equal to 2. That is our slope-intercept form. So that describes the same graph that we've already constructed, but the equation of the line is in a different form. So from this information, we can identify the coefficient of x as the slope. So the slope of our line is negative 2/3, and this constant gives us b. Our y-intercept is 0, 2. Well, we can already see we've got the y-intercept over here. Let's double check our slope. So if I measure the rise and the run from the y-intercept, I'm going to count down 2 and right 3. And notice that gets me to the next point on the line. So our rise is negative 2 and our run is 3. So remember, if the line is initially presented in slope-intercept form, I would start by plotting the y-intercept and use the slope to count my way to the next point. But if my line is given in general form, it's pretty easy to plot it if you just calculate the x and y intercepts. Okay, let's practice this again on example 8. Graph the line 5x minus 2y equals 10 by plotting the x and y intercepts. So again, we're starting in general form. So let's begin by finding the x-intercept. To do this, we set y equal to 0. So we have 5x minus 2 times 0 equals 10. 2 times 0 is 0, so we arrive at the one variable equation, 5x equals 10. Dividing both sides by 5 gives us the value x equals 2. So it looks like our x-intercept is ordered pair 2, 0. I'm going to go ahead and plot that on the grid. Ordered pair 2, 0. Next, we'll find the y-intercept. And the procedure for finding the y-intercept is to set x equal to 0. So we go back to our original general form, and we're going to replace x with 0. Of course, this means we lose that first term, and we end up with the one variable equation, negative 2y equals 10. Dividing both sides by negative 2 gives us a y value of negative 5. So the ordered pair for our y-intercept would be 0, negative 5. So let's plot that on our graph. 0, negative 5. And then carefully connect the dots to graph the line. Arrows on the end of that line. And we'll go ahead and label it with general form, 5x minus 2y equals 10. Now, before we answer the rest of the question, let's make a prediction. Let's look at our graph and let's measure the slope, calculating the rise and the run. So notice our rise would be 5 and our run would be 2. So we can predict the slope of this line is going to be 5 over 2. Let's see if that comes out of the algebraic work. We're going to solve for y to find the slope-intercept form. So we begin with our general form, 5x minus 2y equals 10. We'll subtract 5x from both sides, and this time I'm going to put it in front of the 10. Remember, we're going for the form mx plus b. And then we'll go through and divide all three terms by negative 2. This isolates y, and we can write that negative 5x over 2 as, and I'm observing here negative divided by negative is positive, so we call it 5 halves x, and 10 divided by negative 2 is negative 5. So there's our slope-intercept form. The coefficient of x tells us the slope, and exactly as we predicted, we come up with 5 halves. This is the b part of our slope-intercept form, so our y-intercept is 0, negative 5, and we can see that we have that here. So you want to be fluent in all of the different types of lines, forms of lines, the point-slope form, the slope-intercept form, and the general form.